Good afternoon, and Evans. My name is Joshua Hernandez, and today I'm here to talk about a serious problem affecting many families in Chicago. This problem is the lead contamination in their water. As you being the CEO of Elevate, you understand the importance of providing clean and safe drinking water, especially in places with high levels of lead contamination. Your company has done a great job in replacing old pipes and installing water filters to have safe drinking water. So today I want to present a solution that I have made so that we can fix the problem of Chicago using chemistry. Well, specifically steel chemistry. First, I'm going to talk about what is lead. Lead is a heavy metal with the symbol of the letter P and B, and the atomic number of lead is 82 on the periodic table. When it's freshly cut, it looks bluish white color, but then it turns gray when it's exposed to air. Lead mainly comes from a mineral called galena. In the past, lead was used in many products like paint, pipes, and gasoline, but because it's very toxic for us humans, it's now been decreased. Now, lead is mostly found in car batteries and radiation shields. Lead doesn't break down in the environment, which means it stays in the soil and water for a long time. This is harmful because lead can poison plants, animals, and people. When lead gets into the soil, it makes the soil toxic and harmful to the plants. These plants can't stop growing properly or even die. And when animals eat these contaminated plants, the lead moves up the food chain, affecting all the animals and humans. In water, lead can poison fish and other aquatic animals. It can cause health problems and sometimes death. Now, lead is especially dangerous for humans. The maximum amount of lead allowed for human consumption by law is 0.015 milligrams per liter. Lead in drinking water can cause serious health problems, especially for children and pregnant women. For kids, lead can affect brain development and cause learning problems. For pregnant women, lead can affect the baby's development and cause loss of birth weight. For everyone, lead exposure can damage the brains, kidneys, and other organs. It can even mess with our nervous system, taking control of our body. Now, let's take a look at the problem in Chicago. Right now, there's a big issue with lead contamination in the drinking water because of the old pipes. This affects 39,000 homes. Each household uses about 300 gallons of water a day, which is about 1,134 liters for a family of 4. This means that the total amount of contaminated water in Chicago is 43,530,000 liters. This is a very serious health problem for Chicago's residents. And sadly, about 130,000 kids have died because of this contaminated water. Therefore, it's very important to find a solution to this big problem quickly. Now, let's talk about the chemical solution to this problem. We can use a simple chemical reaction to remove lead from the water. I am going to explain the reactions involved in the solution. First, carbon dioxide reacts with water to form carbonic acid. So this will be written as CO2, carbon dioxide, plus H2O, water, forms carbonic acid, which is H2CO3. Now, lead-2 hydroxide is formed when there is lead in water pipes, which then later reacts with water and oxygen. So this forms lead-2 hydroxide. So carbonic acid reacts with lead-2 hydroxide to form lead carbonate and water. This will be written as H2CO3, which is carbonic acid, plus PbOH2, which is lead-2 hydroxide, forms a PbCO3, which is lead carbonate, plus H2O, which is water. Lead carbonate is a solid that does not dissolve in water. This will make the lead be easily removed through filtration. This makes the water safe to drink by reducing lead contamination effectively. Here's the model I made showing how this process works. First, the contaminated lead water, or in other words, the lead-2 hydroxide enters the tank. Then, carbon dioxide is bubbled into the water, creating carbonic acid. The carbonic acid reacts with the lead-2 hydroxide to form lead carbonate, which precipitates to the bottom of the tank where it can be easily collected or removed. Finally, the clean water that does not have any lead goes into a separate clean tank. By doing this, we have easily solved the big problem of lead contamination in Chicago. Now, let's go through the data and calculations. In Chicago, the average use of water per home is 300 gallons per day, which is 1,134 liters for a family of 4. With 38,385 homes affected by lead contamination, the total volume of contaminated water is about 43,530,000 liters. Now, we have two questions that need to be solved. First, in question 1, we need to figure out how much carbon dioxide is needed to treat the amount of water contaminated in Chicago. First, we need to calculate the number of moles of lead 2 hydroxide in the water. We need to start with a given concentration of lead 2 hydroxide in the water. Its concentration is 25 milligrams per liter. Then we need to convert milligrams to grams. Since there are 1,000 milligrams in grams, we need to convert the concentration from milligrams per liter to grams per liter. Now we need to multiply by the total volume of water, which is 43,530,000 liters. Now we convert grams to moles, and we need to divide it by the molar mass of lead 2 hydroxide, which is 241.21 grams per mole. This will make the result of 4,511.62 moles of lead 2 hydroxide. Now we need to calculate the number of moles of carbonic acid needed to react with lead 2 hydroxide. 1 mole of carbonic acid reacts with lead 2 hydroxide. This means that the number of moles of carbonic acid needed is equal to the number of moles of lead 2 hydroxide. Since we have 4,511.62 moles of lead 2 hydroxide, we need the same number of moles of carbonic acid to react with it. So we start with 4,511.62 mole of lead 2 hydroxide, and we multiply it by 1 mole of carbonic acid and with 1 mole of lead 2 hydroxide. This will give us 4,511.62 mole of carbonic acid. Then we calculate the number of grams of carbon dioxide needed to produce 4,511.62 mole of carbonic acid. 1 mole of carbonic acid is produced from 1 mole of carbon dioxide. So, the number of moles of carbon dioxide needed is equal to the number of moles of carbonic acid required. We need to convert the moles of carbonic acid to carbon dioxide. Then we need to convert the carbon dioxide moles to grams. The molar mass of carbon dioxide is 44.01 grams per mole. To find the total mass of carbon dioxide, we multiply the number of moles by the molar mass. This will give us 198,556.78 grams of carbon dioxide. Therefore, we need 198,556.78 grams of carbon dioxide to produce 4,511.62 moles of carbonic acid. So, the answer to the question 1 is that we need 198,556.78 grams of carbon dioxide to treat 43,530,000 liters of lead contaminated water in Chicago. Now, for question 2, we need to figure out how much lead is precipitated when the reaction happens in percentage. First, we need to calculate the molar mass of lead 2 hydroxide. Lead has 207 grams per mole. Oxygen has 15.999 grams per mole times 2, that would equal 31.998 grams per mole. Hydroxide has 1.008 grams per mole times 2, which would equal 2.016 grams per mole. The total of grams per mole of lead 2 hydroxide will be 241.014 grams per mole. Now we need to calculate the percentage of lead in lead 2 hydroxide. So we need to divide 207 grams per mole by 241.014 grams per mole times 100. Our answer would be 85.89%. Or we could make it into a decimal, that would be 0.8589. Now we calculate the amount of lead precipitated. We have 4,511.62 moles of lead 2 hydroxide. We multiply the number of moles by the percentage of lead. So 4,511.62 moles of lead 2 hydroxide times 0.8589 equals 3,875.03 mole of lead. Now we convert the moles of lead to grams of lead. So we need to multiply 3,875.03 mole of lead by 207 grams per mole, and it will equal to 802,131.21 grams of lead that precipitates. So the answer to question 2 is that 802,131.21 grams of lead will precipitate when the chemical reaction occurs. In conclusion, my calculations show that we need 198,556.78 grams of carbon dioxide to treat 43,530,000 liters of contaminated water in Chicago. This solution can help reduce lead in water, making it safe to drink. By using carbon dioxide and lead 2 hydroxide, we can make the lead form a solid and it can be easily collected and removed from the water. Doing this will help make the water safe to drink and will achieve the goal of having clean water and sanitation for everyone in Chicago. Using these chemical reactions, the problem of lead contamination in Chicago can really improve the health and safety of people there. This solution shows how stereochemistry can solve big problems like water contamination. By using the solution, organizations like Elevate can show their dedication of helping the environment and public health. This solution can also inspire other cities to use similar methods to clean their water. This solution will work perfectly if it's tried in Chicago or in any other place that has the same contamination problem of lead. Thank you for your time, Mrs. Evans. I hope that this solution can be very valuable for your company, Elevate, and its efforts in providing clean and safe drinking water. If you have any questions, I'll be happy to answer them. Thank you very much for your attention.